Deepseek, Deepseek, Deepseek. It's the buzz on everybody's mind. It's the new hotness. Why did everybody notice Deepseek? Like, things have been really amazing for a long time before Deepseek. Deepseek is tangible to the most people. They've all heard of it. Things are, Sputnik moment. We're on the precipice of a second industrial revolution. That much is true. And with all the good, and probably all the bad, that the first industrial revolution brought, AI is coming like the steam engine came, and Deepseek is a particularly good model of steam engine, I think. There's no reason not to run it locally, though. And you can. Running it locally means that your data never goes to the cloud or anywhere, and there's no danger from somebody stealing your stuff or even knowing what you asked the AI, taking files off of your computer. It literally runs all locally. You can do it. Here, take a look at this terminal. I'm running Deepseek R1, the full 678 billion parameter model on AMD EPYC CPUs on a Supermicro server at upwards of 10 tokens per second in most scenarios. No cloud, no GPUs even. No one is getting a copy of the inputs or outputs. It's all local. This is one of the most economical ways to run these giant models. And I think this is important. I think this is important for the future of humanity. It's supposed to be like a Futurama type. The world of tomorrow. Let's take a closer look. First, this video is a little bit how-to, but it's also a little bit rambly because I want you to understand at least my headspace, where all this is, the things as I see them, because there's a lot here, and there's going to be a lot that I can't get into because there's just not enough time. But maybe a series of videos if it's interesting enough to you, and you comment, let me know, and engage, and whatever. For the impatient among you, there's chapter markers. You can just skip right to it. If you just want to get started right away, there's two places that I would point you to: LM Studio and Ollama. And you can get started immediately with LM Studio, and if you're a little bit more of a gearhead, Ollama plus Docker plus Open Web UIs. LM Studio is more noob friendly, and it lets you run a lot of large language models locally. You can use your GPU or GPUs, you can run it just on the CPU, whatever you want to do. The demo here is running on just llama.cpp, which we'll talk about. Now, these options are the software equivalent of the shallow end of the pool, and we're going to go a lot deeper than that. Llama.cpp is more toward the deeper end, llama.cpp with patches. I've got a lot more to say about that, probably around here, or this chapter marker. So, yeah, look at that. Alright, first, let me set the stage. The Industrial Revolution. The steam engine. We're replacing labor with machines. And then there was a proliferation of machines and new tools and new ways of approaching things. It even led to much more new medicine. It also led to child labor, which is not fantastic, and some social and societal upheaval. The steam engine displaced a lot of manual labor, but almost paradoxically led to a rise in average wages for both men and women. From a capitalist standpoint, the owner of the factory was able to capture more of the value of the labor than the individual had been, at least up to that point in history, which was not great for workers, really. I mean, yeah, higher average salary, but I mention that because for you, dear viewer, you at least stand a chance of understanding and leveraging AI to better capture the value of your own labor. And so I think in that context, the industrial revolution before us is maybe going to be a bit better for the individual. We're going to see the billion-dollar sole proprietor company, wherein the value of the product is the software running on top of someone else's infrastructure, and whoever came up with that is going to be able to capture almost all the value from that. It's true that in this AI-fueled second industrial revolution that's coming, it is likely to displace a lot of jobs, just as the steam engine did, but not the labor jobs. It's going to be the rank-and-file office jobs, people sitting at a computer clicking buttons all day. And I am worried about that part of it, but time marches on. If you're fiercely independent and you have a lot of drive, right now at least, the system is not as much rigged against you as it was perhaps in the past, as it was perhaps against the laborer in the Industrial Revolution. You may yet be able to capture more of the value of your own labor with AI tools. I think that's the hope, and I think from working on this, you Yeah, I mean, Amazon. Take a look at Amazon. Amazon's a $1 trillion company. How? Their EC2 services. You can programmatically buy compute and storage resources. You can just come up with a program and say, hey, this is what I need. What Amazon sells in their cloud, that's what's propelled them to $1 trillion companies, the margin that they make on just selling hardware. But isn't that a commodity? Isn't that like steel or corn or something? With a normal market, this is just going to devolve into a commodities market. Who has the cheapest compute? Who has the cheapest storage? We'll just provision resources on them, and cool. I come up with a cool app. A lot of people want to use it. Fun game. Something that I've developed. I shall provision space and resources for my users on whatever is the least expensive and functional for something that's fit for purpose. And in our AI world, it may be possible for that sole proprietor to establish themselves and grow their audience and build a company and capture $1 billion of valuation. Their work product, the code, whatever is running, even if it's running on someone else's computer, is always under their direct control. I think that's awesome. I think that's probably the future. I think a lot of companies are really scared of that future, and they want to own the AI. AI running in the way that I'm going to show you in this video can be a tremendous force multiplier for people that have that kind of agency. I hope that's you, or I hope I'm sending you off in that trajectory. I hope I'm lighting a fire under your butt to get it done. If you have a crazy idea, or you're an inventor with some wild thing that you want to discuss the feasibility of off the record and absolutely safely on locally running AI, well, you can, because it's never going to leave. It's never going to go to the cloud. Your machine is not going to surreptitiously send that somewhere else. It can help you learn more about what you don't know, which is usually where the pitfalls are. And every day, these AI tools get more effective at helping you see your own ideas through. As an individual, you can rent your own stuff in the cloud, your own private GPU. It's about $3 an hour per GPU, and a Deepseek is 671 billion parameter model. You need about 600 gigs of VRAM, 1.2 terabytes if you want to export it to FP or BF16, but it's natively it's an 8-bit model, not 16-bit. Deepseek is natively FP8 for cost savings reasons, but for some types of experimentation, you would need to convert it to BF16. And if your cloud provider is unscrupulous, maybe they're spying on you. But there's other ways. I'm sure you've seen like 1-bit models or 1.5-bit or 8 billion parameter distilled versions of Deepseek. But let's talk about the model before we get into that, because some of that is not exactly the same. Some of that is probably not what you think it is. Deepseek caught everyone's attention because, the researchers added an inner monologue that you can see the chain of thought. And so if you ask the AI how many R's are in strawberry, you can see the steps that it's going through. This helps prevent hallucinations. You can see it thinking, in essence. You can see into its inner monologue. IBM had a pretty good write-up of what this meant for the industry from IBM's perspectives, or an IBMer's perspective, which is interesting insight into the industry, but also the things that are happening. So you should read into both of those things in this article. It's a reasoning model. It cost $5.5 million to train. That seems like a lot, but not really. This model leverages another clever thing called mixture of experts. This is actually an old idea, but think of it, I'm oversimplifying here, but there's a bunch of neural networks trained differently in kind of a trench coat acting as one. It's the trench coat, squirrels meme. It's a bunch of trench coat. Yeah, it's like that with AIs. Load the whole thing into memory is still the thing that you have to do, but it's really only working with about 1/8 of the model size, or about 70 to 100 gigs of VRAM is all that's really hot. But you still have to load the whole thing, which 600 gigabytes is not amazing. But there's a lot of work being done by a lot of different teams with a lot of different approaches to try to make this more efficient. Neural magic, IBM just bought them. That's one approach. There's a lot of papers that are working on other ways of approaching that. Swap MOE, I think, is one paper that looks really promising. It proposes a technique for swapping the layers of the neural net in and out, depending on which AI is in the trench coat is concerned with a particular query, which AI is being used, in other words. Other approaches, like what Unsloth has done here, this is the dynamic sparsification to make it about 1.58 bits, and it's much higher fidelity. The closer the model output is, to the big model, the more bits you get. But that they've been able to do this in like 2.5 bits, almost 3 bits, pretty good. There's also distillation, which is another different thing other than quantization, and those are different quantization techniques. A Deepseek's page on Hugging Face has models like Deepseek R1, Distill, Llama 70B. Wait a minute, isn't Llama from Meta? What's going on there? It's not really the Deepseek model. Instead, this is the Llama model that has been trained, or taught, if you want to think of it that way, by Deepseek. So the output of Deepseek is training Llama here. And yes, it improves the Llama model, but fundamentally it's not really Deepseek, at least if I understand that correctly. When we're looking at the Studio LM website and the various models, you'll see that sort of at the bottom. It's like, is this Llama, Quinn, which model is this? Because by themselves, Llama and Quinn may, and many more, are good AI models. You can be doing a lot of useful stuff with different models right now, and different models may suit your needs differently. And then this is even before we get into image generation and all that, which is a whole other different thing. Here in this demo, I asked Deepseek to create a Python clone of Flappy Bird, because that's going to be not a very long query, and it's going to be a very long response. And it might seem slow, but we're running Deepseek without any GPUs. We're just running this on CPUs, and we're humming along at about 10 tokens per second. Now this machine is kind of fancy. It's on a dual processor EPYC 9684X running on a Supermicro 2125HS TNR. Those are fancy Vcache CPUs, which should help with memory bandwidth, and they do, but it doesn't make a huge difference, at least not for right now, because the software, I think, is wildly unoptimized. In my experiments, the name of the game seems to be memory bandwidth. And well, you can get some inexpensive EPYC CPUs that'll support 12 memory channels, and so that's one of the builds on the forum. I've configured the system to run in NPS 0, which actually will like sew the two sockets together in one NUMA node. Probably join us on the forum for the nuts and bolts of this. If the nuts and bolts of this kind of thing excites you, there's a thread and parts lists to help you build these kinds of systems, or at least put some stuff together. And it's like, if you build this, you'll get roughly this performance. If you build this, you'll roughly get that performance. Given the size and complexity of the model, the fact that it's running as fast as it is hugely impressive, because again, no GPUs here. Now for GPUs, the fanciest system that I have is the Supermicro AS2114 GT DNR, and it has up to 6 Instinct MI210s in it. Running this model full fat on GPUs is going to need on the order of 640 gigs of VRAM. I can't even do it with 6 MI210s, and 640 gig ought to be enough for anybody. But I wouldn't actually suggest doing that. It's a limited utility to have such a big system for yourself. I mean, by the time the system arrives, there's going to be software to make you need a lot less system, because that's already happened from the time Deepseek was released around Christmas time of 2024. The quantized Deepseek from Unsloth is quite good. If you run it on a system that has 2 H100 GPUs, you can clear 140 tokens per second. And GPUs are a lot more expensive than just the compute platform, and a lot faster than CPUs, I guess. I mean, okay, a single 192 gig MI300X in the Azure cloud running SGLang was even faster than 2 H100s, at least for this particular task. So that's exciting, that the MI300X, but they're basically unobtainium. And that's on, Supermicro has these systems if you want to buy them with a GPU. What about a Threadripper desktop? What about Threadripper? This is my Falcon Northwest 96-core Threadripper, and even 96 cores may be overkill for this task. One of the nicest things with this setup, though, is that it has 8 memory channels that you can run at really fast speeds. So DDR5 6000 registered ECC with good CL2 timing can give 12 memory channels a run for its money. We've also got 4 Crucial T705 4TB NVMe and a RAID 0 in this configuration, because Threadripper's got all the PCIe lanes. Now this is an interesting edge case. This is something you can do some wild experiments with, where we don't even use RAM for model storage, and that's actually not completely unviable. I mean, you can get 6, maybe 10 tokens per second if you really push things, just using NVMe, not RAM. In this configuration, we eschew loading the whole model into RAM. Instead, we load the KV cache into RAM and load the model from disk. This is a RAID 0 array, and keep in mind those Crucial T705s, they can thump along at 60 gigabytes per second. Linux helps us cache the file system into RAM, but yeah, the mixture of experts model here, because not all of the 671 billion parameters is activated, depending on what we do, only a part of the model is activated. And once it gets cached into memory, then the 60 gigabyte per second bottleneck of our RAID 0 array doesn't matter quite as much. It also doesn't hurt that you can throw a GPU or two in the system with the leftover lanes, and those will help speed things up with additional layers, or offloading some of the layers onto GPU, or whatever it is that you want to do. Okay, hopping straight into LM Studio, I want to show you or talk to you about how you can use your GPU even when the model is too big to fit on your GPU. I've gone to models and I've downloaded the Llama 70B model, 70 billion parameters. So even before we get to Deepseek, because it's quite good, you should play with it. For 8-bit parameters, that means 70 billion. For 8-bit models, 70 billion parameters means 70 gigabytes. And this neural net also has many layers. And the software is such that you can decide how many layers you want to run on your CPU and how many you want to run on your GPU, because our Threadripper system here doesn't have a 70 gig GPU. So your GPU will run fast and your CPU will run slow, but you can squeeze some performance out of both of them running at the same time. So some models on the GPU, some models on the CPU. It's a perfectly reasonable thing to do, but you'll have to experiment a little to find the optimal configuration. Also, check this out in LM Studio. Does it collect data? No, it does not. This is awesome. Everything is running locally. Also in LM Studio is the ability to do something called Retrieval Augmented Generation, RAG. You'll see this everywhere in AI stuff. You can upload your documents, and RAG and uploading your documents could actually be its own video. The best setup here, if you're going to go down this rabbit hole, is you download a model that is specifically built to analyze and index and summarize your documents. And so when you upload a document, it'll do that. It'll look over and produce a summary, and then you can feed that summary to another AI that you're actually interacting with. And so you're talking to an AI that has, a summary produced by another AI with your documents. With LM Studio running, you can plug it into Visual Studio Code if you're a programmer. So you can also expose LM Studio to your network or your local machine. You can allow other machines to ask queries to models running on your machine over your LAN, and it has a good GUI for you to be able to do all this stuff. So what's stopping you? It's dead easy. And before you load up your ancient, gnarly, huge code base, you probably should also understand context. A lot of my examples are short questions with very long answers. These tools also have this idea of context. The neural net needs maybe a longer context more than just my short query to give you a better answer. Context is how many tokens the AI has in the context of processing that it is doing now in response to your query. So it could be a longer query, and then the response itself is a certain number of tokens. The more context, the more tokens of the response, the more memory. And most models have fundamental context limits, and so you can see these in the GUI most of the time to know what you're working with. So in the GUI you can play with the context length and maybe save some memory, and there's options. There's also Ollama that I mentioned before. It's a similar idea to LM Studio, but it's more oriented at gearheads. Ollama is just a service that runs in the background and provides a model or models. It doesn't really give you a GUI out of the box. I actually prefer this one because it's a little closer to that llama.cpp that I mentioned before, but there's something called Open Web UI that's front end for it. This is one of the most extensible options you can do for your AI experimentation, and actually inside Ollama is llama.cpp. Everything cool and on the bleeding edge on the internet right now pretty much sort of kinda is in llama.cpp. Public patches and not so public patches, especially the swap MOE, the swap mixture of experts things, and AVX 512 experiments. There's a lot of stuff going on with llama.cpp, but that's a story for another day. A lot of excitement with that project, so check out their GitHub. There's a great thread of information on all this stuff on the forum that goes with this video, and many threads that predate it. For people that have seen just how empowering these AIs can be when you have them locally. The unsloth models for Deepseek were so good that I decided to try the 2.58-bit models on a 24-core Threadripper. And then I also added 1 and then 2 RTX Ampere generation A6000s to the system just to see how it worked. Now, CPU only, with the Q2K XL model from Unsloth, we could get 7.67 tokens per second for token generation and about 26 tokens for prompt processing. This is just a fact of the platform has 8 memory channels because it's Threadripper Pro, and it's 24 cores, 7000 series Zen 5. We also did experiments with the quadruple T705 Crucial setup in the 24 core system. A forum user, Ubergram, and I put together and did a bunch of testing. There is a link actually below. You can take a look at the gist on GitHub. There are also updates to llama.cpp, not just the mixture of experts patch that's coming, swap MOE, but there are other patches where people are saying, hey, maybe we don't actually need to load the particular expert that we want here. You should understand that in a large service provider, these patches don't make sense because you've got so many people using the GPUs that all the experts need to be loaded in VRAM. It's only in the single user context where I'm just going to run a query and you can give the model a moment to think, when it's really just swapping the expert around, that this use case makes sense, where you could load a 40 or 80 gig GPU with the one expert out of a 600 gig model. But still, the selective quantization that Unsloth has done seems to be one of the most effective Deepseek models out there that'll run on more modest hardware. The fact that you can get 7 tokens per second on just pure CPU is fantastic, even if you don't have 768 gigs of system memory to run with. And right now, at least with the software in the state that it's in, the fast storage is definitely not as fast as it could be. So that's something that's going to need a little bit more work. Oh, and this is another popular thing on the forum. 23090s with an SLI bridge, guess what? That's one GPU with 48 gigs of VRAM, because you get 224 gig VRAMs. This is there's a dude on the forum that straight up traded an FE 4090 for an EVGA 3090 Ti because they were going to do the bridge thing and run with 48 gigs of VRAM. And yeah, that was pretty crazy. The 3090 is no slouch for AI. You really can't get it to work exactly the same way with a 4090, and whatever they were doing benefited from having the bridge. So that was kind of wild. 70 billion parameters, if you quantize that into 4 bits, it'll also require half as much VRAM. So if something that's 70 billion parameters, you can get to run in a 48 gigabyte GPU if it's 4-bit instead of 8-bit. So yeah, but use the layers thing to mix CPUs and GPUs. I hope you like this video, and I hope you have questions. I'd like to do some more work here because this is, I think, one of the best things to happen to humanity, and being alive at this exact moment in history is actually incredibly exciting when you realize the power that these tools can give an individual that has agency, and in a way that you can put your arms fully around it. There's not a catch or a gotcha. I bet we'll get to a future where there's a lot of co-ops of people, just like you and me out there, pooling our effective compute together to train models for the good of humanity. Because Deepseek needed a lot less training hardware and overhead, and shows that it can be done. You just have to be more clever and develop more software and do awesome things. So with these tools, we'll probably be able to capture more of the value of our labor, and that seems like that's going to be good for society going forward. I'm Wendell, this is Level 1. AI is incredibly exciting. You'll find me in the Level 1 forums. Let's hang out, touch base, whatever. Download LM Studio, and let me know how it transformed your life. All right, I'm signing out, and I'll see you there.